Friends, welcome back to the Boolean Brain. In continuation to the LeetCode Daily Challenge series, we are here on the day 3 of the month to solve the today's challenge. Try to take a look at this one. Title says number of ways to paint n by 3 grid. You have given a grid of size n by 3 and you want to paint each cell of the grid with exactly one of the three colors. So there are three colors given to us: red, yellow, and green. While making sure that no two adjacent cells have the same color, that is, no two cells that share vertical or horizontal sides have the same color. So we have to basically color a grid and we have to ensure no two adjacent either horizontally or vertically share the same color. Given n the number of rows of the grid, return the number of ways you can paint this grid. As the answer may grow large, the answer must be computed modulo 10 power 9 plus 7. Okay, so yeah, after reading at this problem statement, we have been given only n, value of n, and the constraints are n can go till 5000. So if the constraint is given as n, so total number of maximum grid can become 5000 into 3, because that's the total number of columns that have been given to us. So another important thing to notice here is the total number of columns are constant, which is 3, and the total number of colors which we want to use is also 3: red, yellow, and green. So this can be a good hint to optimize this problem statement further, but as of now we don't know anything, right? So let us try to understand this first with some examples, and later on we will go through the brute force and then try to optimize it further. So first try to understand this problem statement for n equals to 1. So when n is equal to 1, how does the grid look like? Something like this. There are three places which can be filled with some color. So for the first color, you tell me what is the option that we have. We have three colors: red, yellow, and green. So in order to make it simplify, let us make it numerical. Y goes 1 and green goes 2. So now since we are having these three positions, what is the possible value for the color in the first location? Can I fill red, can I fill yellow, or can I fill green? I can fill all the three, right? So if I just go ahead with 0, it looks like this, and I don't know about the rest. If I can also fill 1, I can also fill 2 in all the three positions. So my first value can contain all these three positions. Now what about the second position? Now while choosing the second position, since the left already contains the 0, I cannot put 0 again here. So the left options available with me for the second position are 1 and 2. So it looks like it looks like this. The available options are 1 and 2, and third we have not yet discussed. Now for the first one, if I go ahead with keeping 1 in the first position, now what are the available options for me to keep in the third position? Can I place 0? Yes, because it is again satisfying the condition that no two adjacent values contains the same color. So I can keep this. At the same time, I can also keep 2. I cannot keep 1, but I can keep 2. Yes, I can. Now for this one, if I am choosing value 2, which is the green color in the second position, what is the option that is available for me in the third position? I can choose either 0 or I can choose option 1. Again it is fine, correct? Now when I'm choosing option 1 in the first place, what are the available options for me to keep in the second place? Can I keep 0? Yes. Also, can I keep 2? Yes, I can. Now for the third position, if I am keeping 0 here, can I keep again 0? No. I can keep 1, yes. Can I keep 2? Yes, I can keep. Now, when I had 2 in the second position, what are the available options for me here? Can I keep 0? Yes. Can I keep 1? Yes. Can I keep 2? No, I cannot. It will be repeated. Now, when 2 is in the first position and I want to go for the next position, what are the available options? Can I keep 0? Yes. Can I keep 1? Yes, I can. Can I keep 2? No, I cannot. Now, when I am at the third position, what are the available options? 0, not 1, I can. What are about next? 2, I can. Yes. Can I keep 0? No. So these are the two available. Now when for 1 is in the second position, what are the available options? 0, yes. Can I keep 1? No, I cannot, because 2 is the adjacent. Can I keep 2? Yes, I can. So when my n is equals to 1, I had only 3 positions to fill, right? For these 3 positions, these are my possible colors. How many are these? 2 plus 2, 4, 6, 8, 10, 12. So these are the 12 possible color options for the n for 1 by 3 grid. Now, so as you can see, for only 1, these are the possible combinations. When n is equals to 2, again these values keep changing. Now try to briefly try to understand what would be the next change. When we had n is equal to 1, that is only one row, we did not consult with the vertically. We only checked if while placing any element of any color, I only checked if it is matching or not with the adjacent. But when the matrix grows, when n is more than 1, we have to take care of that as well. For example, yeah, so if let's say in the first case I got something like this. So my first row, for example, some colored with something like this. What are the available options for me in the second row, first column? Can I put 0? No, I cannot, because it is already at the top. Can I put 1? I think I can put 1, because 1 is in the diagonal and there is no condition of restriction on diagonal. So I can keep 1. What are the available options in this second position, 2, 1, 1 position? So at this position, can I keep 0? I think I can, because 1 is neither uh, matching with the vertically not with horizontally. I can keep 0. For this last position, can I keep 0? No, it cannot. It is matching with both left and up. Can I keep 1? I think I can. So this way, this is one possible color combination of the grid when n is equals to 2. Similarly, I need to take care of all the other places. So what is the brute force learning from this? Are we now able to code brute force? I think I can. I think I can. And it is not so difficult. The problem statement, after looking at it, it looks hard, but it is not at all hard. Trust me, I will code a brute force. I know it will not be accepted because constraints are pretty high, but still, just for the understanding and the conceptual point of view, I will code the brute force approach. And another important thing and hint is, whenever such combination trial and cases are present, the only available solution is recursion. So the solution must start such problems are always solved through recursion. So recursion is the one which helps us give the brute force approach, and later on, by adding some enhancing that brute force solution to using some memoization technique, we can convert it into the dynamic programming solution. Okay, now try to solve this with the help of the brute force approach. Now for the brute force approach, what I will do, I will simply create a helper function. So this helper function, so as of now, what all I need for the helper function? So my brute force approach is, whenever I am iterating on the grid, I want to ensure I would move on cell by cell, and each position I can check if I can, out of all the three colors, can I fit any one of the color. If I can fit any of the color, I will simply assign that color to that cell and move on with the next cell. So this is my simple brute force approach. So in order to do that, what do you think would be the states that I would be needing? Would I be needing the cell coordinates? Yes, that's the only thing that I would need. Cell coordinates are, initially I will start from 0 comma 0, which are 0 I comma j. Now next, another thing that I would need is the grid. So I also need to declare a grid. So grid is nothing but our 2D matrix. The total number of rows are n and total number of columns are comma 3. Total number of columns are 3 and the default value that I am initializing is -1. Okay, this way it is declared. Now I want to complete this helper function. It took j, it also took vector. Okay, now now as you might be aware, some recursion fundamentals are essential to understand this. Now helper is going to be the recursive function, and each recursive function has a base case. So what is the base case for this, or the terminating case on which I can assume my answer is over? Now I am iterating row by row, cell by cell, right? Cell by cell. And what would be the terminating condition? When my I becomes equals to the n. Is it correct? Yes. If I is exactly equals to n, it means our in row, while iterating, we completed all the cells, and now our row pointer is at the nth position, correct? So at that point, what I can understand is, if I'm able to iterate all the cells and reach beyond the grid, it means my total, I was able to fill all the colors. So there is at least one possible case which is giving us the answer. Okay, now I am at the I comma j cell. I want to fill some color. What are the available colors with me? Three colors available with me, which are 0, color is less than 3, color plus plus. These are the three colors, like 0, 1, 2. Now I want to try if I am able to put one of the color right from 0 to 2 in each location of ith comma jth. So I'll simply do if, now in order to satisfy the current color in the I comma jth position, I need to ensure what are my previous up, what is the my upside and what is to my left side. So in order to fetch that value, I need to get this in previous left, isn't it? So in order to go previous up, my condition is it I minus 1 row should be present. It should be present, right? So if I can only access the previous element if I minus 1 index, if this is the rowth index, if it exists. If it exists, what is my previous up value? Grid of I minus 1 of j. If not, I can simply keep -1 as the default. Yes, I can. Now in order to go previous left, I need to check j minus 1 because column is denoted by j. If it is greater than equals to 0, what would be the previous left? I j minus 1. Is it correct? Yes. If it is not, if this condition is not satisfying, what would be the default case? Minus 1. Now, since I have previous up and previous left, I can simply write the condition. Previous condition would look like if my previous up is not equals to color, if my color is not matching with previous color, and previous left is not equals to color. Isn't this the only condition that we need to care while substituting the current color in the I comma j? Yes, I can. If condition is matching, I can simply add I comma j to the color, and once I substituted the current color on this location, I want to make a recursive call. I want to move to the next cell. How can I move to the next cell? I am currently at I comma jth, so the next cell would be I comma j plus 1. So I will try to find out the new ith and new jth. So let's assign new ith to current I, and the new j equals to current j plus 1. Now here is one condition: if my current j is exceeding the 3, because the total number of columns are only 3, right? Once it is exceeding 3, we have to move to the next row, correct? So I can add a condition: if next j is greater than equals to 3, I can update the I to I plus 1, correct? And new j becomes 0, because whenever a row is exhausted, it should move to the next row, correct? Yeah. And yeah, that's the case. Afterwards, what I also want is, I want to update the answer. What would be my answer? Answer equals to answer plus helper of new I comma new j comma grid, isn't it? Because if I want to move to the next cell, whatever the answer written by the next cell, that I should return. So I am just appending the current answer value. So I have not yet declared the answer, so let me declare the answer. Okay, answer plus grid. Okay, great. I think we are good. Yeah, one more condition, so that it has mentioned that the answer must be computed modulo 10 power 9 plus 7. So I'll declare the mod 1e9 plus 7, and whenever we are calculating this answer, modulo mod, because this is the mod, correct? And at last we need to return the answer. I think it should work. Let's try and run this. There is some error at line number 9. It says if I is exactly equals to n. Okay, n is missing here. So what we can do is, we can fetch the n, line number 50. Okay, again, so this will not be accepted. This is just a brute force approach. Okay, I'm just writing this so that you understand how we can write a simple recursive function based on the given conditions. Yeah, so it is time limit exceeding because the input is high. If I just reduce the input to maybe 7, I'll also add another test case which 5. So for test cases less than 10, I think it should work. Yeah, as you can see, all the answers are matching. But whenever the input test case raises beyond 12, beyond 10, it basically gives us the time limit exceeded. Now try to understand the time limit, like the time complexity and the space complexity. So what do you think is the time complexity of this? What are we doing here? So we are trying to fit these three colors in each location. So what is the time complexity? Isn't it exponential? Yes, it is exponential. So we are trying three possibilities on what are the total number of cells available? It's n cross 3, so it's 3n. So this is the time complexity for this approach. And what about the space complexity? Are we using any space apart from grid? I don't think we are using any space, so it's just the O of 3n. Again it is turning to O of n. So this is the time and space complexity. If I want to submit it, I can submit this just for to ensure it will not get accepted. Now the main thing is we want to optimize this further. Yeah, it is time limit exceeded. So we want to optimize this further. How can we optimize this? So what is the case that we were doing in the earlier case? In the earlier case, we were iterating cell by cell, but I mentioned that there is a hint. There are only three colors: red, yellow, and green, and the total columns are three. So instead of iterating cell by cell, can I do one thing? Instead of iterating cell by cell, can I iterate row by row? Can I iterate row by row? So for example, if I have in the my starting case, let's say if this is 0 1 0, so in order to come up with this entire row at once instead of going one by one, what are the conditions for this? If I am at the ith position in this row, second row, I need to look left, I need to look upwards, I need to look for this left doesn't exist, so I need to look at the top. For this position, in order to match, I need to look in the top and in the left. For this position, I need to look at the top and at the left. So how many conditions? So three vertical and two adjacent, so total 5 conditions. So in order to come up with the entire row, I only need to ensure, I need to certify these 5 conditions, which are 3 up and 2 adjacent. Now you might ask, like, where will be these values come from? These values will be our trial and error. So what is trial and error? What are the options that we have? For this, I can have value between 0 to 2. Similarly for this, again I have 0 to 2. Again for this I have value 0 to 2. So these are the only available combinations for of the colors in for this row. Okay, so for this, what we will do is try to now solve this using this hint. Now similarly, I'll create another helper function which would be a recursive okay. Now I want to write this recursive. Now I mentioned that I'm thinking of this row, I'm only thinking of this row. So in order to work on this row, what in order to find the values at this row, what values I need to consider? All the values from previous. So can I have three variables like p1, p2 and p3, which would be required in this helper function, p1, p2, p3, correct? Now what else? I am working at the row level, so I also need a row indicator. I need to start with 0. Yes, 0 is my first row. Now let's try to write the function definition for the helper. Int helper int, this is my row, let me write with I for simplicity, and these three, int p1, int p2, int p3. Okay, now when I am at the ith location, it means I am initially it is set to 0. I want to fill the 0th position, so the input is like this, and there is no row for upward. So what are the conditions that I need to check? I can simply assign previous to -1. Yes, I can. So let me do one thing, let me assign this with -1. Okay, so my initial previous for my first row are -1. So again this is a recursive, so there would be some base condition. Okay, now what would be the base condition? Will my base condition remains the same with as of previous approach? Yes, it would be if my I exceeds or becomes equals to n, at that point my answer would increase by 1. Correct? Else, now let me assign answer to 0 and return answer at the end. I don't know what will come inside. Let's check. Now what does this p1, p2, p3 define? It mentions us that all the previous values for from the current row. Now we are working on, let's say, this the first row itself. For this position, what are the available choices? 0, 1, 2, all the three. Similarly for this 0, 1, 2, 0, 1, 2. So this loop, how can I get this loop? Yes, you guessed it right. In order to get these three loops, these three values, I need to add three loops. So first loop is for the c1 color. It starts from 0, c1 less than 3, c1 plus plus. Now for the next loop, what do you think? It starts from c2. C2 less than, everything remains the same. Now for the third one, c3. Yes, it is. Now we are having these three possible candidates. So these c1, c2, c3 are nothing but the candidates for this position, and I want to check these total 5 conditions on this candidature. So what I will do is I will add the condition. If my first condition, my c1 is the current candidate, c1 is not equals to p1. P1 is the previous rows element, corresponding element. If c1 is not equal to p1 and c2 is not equals to p2 and c3 is not equals to p3. So these are the three conditions. What else? There were another two conditions. c1 is not equals to c2 and c2 is not equals to c3, isn't it? These 5 conditions which are here, I need to ensure these 5 conditions are met before updating the current row. So I'm initially assigned answer to 0. Now my answer would get updated. So what would be my new answer? Answer plus the recursive call for helper is helper. Now my ith row values are justified. So if my ith row values, now c1, c2, c3 are my current elements. So if I want to log this current element, I need to move forward I plus 1. To move forward, simply make I plus 1, and here we pass the current elements, which are nothing but c1, c2, c3, isn't it? Yes, that's it. So once we are having these three elements, now our recursion function is complete, isn't it? Once everything is done, what we can do is simply return the answer. but it is not yet complete here. So this compute modulo 10 power 9 plus 7, right? So we need to take care of this here as well. Int mod equals to 10 power 9 plus 7. Okay, what we can do is simply modulo mod. Is it correct? Yes, it is correct. Now with this, no, still our solution is not yet optimized. This is the recursion way, but if you want to optimize this, we can simply convert this into dynamic programming by adding the memoization. Yeah, again I missed this. N equals to, okay, I need to pass the n because I did not take that as an input. I also need to pass to the recursion. Yeah, I think with this sample test cases should pass. It is not passing. 1 8 12. Let me quickly have a look. If I is equals to n, return 1. Answer is initially assigned to 0. And c1 starting from 0, c1 less than 3, c1 plus plus, c2 0, c2 less than 3, c2 plus plus, c3 is 0, c3 less than 3, c3 plus plus, c1 is not equals to p1 and c2 is not equals to p2, c3 is not equals to p3 and c1 is not equals to c2 and c2 is not equals to c3. In that case I want to update the answer. Answer equal to answer plus helper of I plus 1, c1 c2 c3 n and modulo 1 in 9 plus 7. Everything looks good. Is there any issue here? p1 p2 p3. It should look good. Rest looks good. Oh, here is that. So c2 is not equals to, yeah, with this again this will not pass for the 500,000. It will only pass for the element input less than 10. So it is time limit exceeded. Now how do we update this? Now for in order to convert this into dynamic programming, there are simple steps. First, what are the states that it is having? So you might ask, we are working on row level. So first at least one is essential. So I need to keep a track of row. Yes. But what are the other values that I need to take care? Because for a cell, if I want to color a cell, this is the ith row and the further state of the output depends on what value is colored at this and what are the total available options for coloring at this 3 0 1 2. Yes, so these are those values. If I am going ahead with the 0th row and on the 0th column uh, with coloring p1 into this 0th, p2 into this first and p3 into this second, what would be the answer? That's how the state will define and be present. That's the reason we are requiring 4D, 4-dimensional DP. So in how to declare the 4-dimensional vector is, so this is 2-directional vector of 4 times vector of int, let's name this as dp. Now how many rows? N rows. The initial first dimension is for the row, so size is n. Now what about the next? So what would the range of this value p1? P1 is initially assigned -1, but in order to store this we would need to update, add 1 and store, so that I need one extra space. So total number of possible options for these are 3 only, 0 1 2, but since we are assigning it -1 initially, I need to store another extra space, that is 4. But I cannot do like this. I need to vector of int of size 4. Now, so this is part of syntax. If you are not aware with the vector initialization beyond 2D, you can take a look. Again 4. So again guys, the video would get a little longer, but I am ensuring that you are coding with me live so that your concept should be crystal clear. -1. Okay, now I need to basically pass this here. Okay, if I am passing it here, I would need to receive it here. I receive it passed by reference, and yeah, I also need to pass it while making the inner recursive call. Okay, so after the base condition, I can basically have the dp check. What I can do is, if dp of ith row with the p1 plus 1, p2 plus 1, again I explained why I'm making +1, because initially my values are -1. I cannot access the -1, it would be index out of range, so I'm adding +1, p2 plus 1, p3 plus 1. If this is not equals to, what did I assign? -1. If this value is not equals to -1, I can simply return the dp value, dp of I p1 p2 p3, isn't it? If the value exists in the dp array, I need to add return the simple value. Sorry, my bad, it should be +1. Yeah, okay, so dp check is completed, and the next stage is, in order to store, if let's say if that value doesn't exist, so all this computation will happen and we will store it at the end while returning. So I will simply make it here. So if my dp of ith row, and p plus 1 I'm making because initially it is -1, it would add -1 to 0, this is 0, this is 0 to my, the answer would get appended here and it would get saved. So let me just try and run this. Yes, sample are passing. Let's run for the submit it. Yes, it is accepted, all successfully passes. Now let us quickly identify the time complexity and the space complexity. What are we doing for the time complexity? We are iterating 3 loops. Again, these are all 3 constant loops, and at max, what is the value that we are gonna be iterating? If we are starting with 0th row, and in each row, for each of the row we are only doing this constant iteration, so can I say my total time complexity is O of n? Yes. What about the space complexity? For space complexity, what is the value what I'm storing this? You might say that we are storing the 4D, but again, if you see the incremental parameter, the variable parameter is only the n, and all the other internal are the input which are fixed of size 4, so it won't constitute much more memory, it would be O of n only. So the time complexity and space complexity is O of n for this optimized approach. And if you are explaining this and coding this in any interview, I'm sure that no one would reject you. Thank you so much. If you are did not understand any thing out of this video or have any queries, please do let me know in the comments. I'm more than happy to answer you all. Thank you.